So, greetings students, and today we'll be seeing, last class we have seen about the Z transform. Okay, so Z transform we have seen. Then we have seen about the ROC. Okay, so ROC is a fixed region of convergence we have seen. So we have seen about what are the properties of the ROCs also we have seen. We have covered those things also. So in the last class, in the properties of ROC, what happened was that there was a problem with this signal, right? So x1 of z, that is, this is after taking your z transform, okay? So after taking your z transform, you got z by z minus a, okay, for this signal, okay? For this signal, we got z by z minus a. So similarly, over here, what you got for the x2 means, for x2 you got z by z minus a. The same only we got, the same z transform we got, but the ROC was differing, right? So the ROC was z greater than a for x1 signal, and for x2 signal it was less than a. Okay, I said I will be referring and saying to you. So now I have got it. So here in general, ROC, what you have to take it is, for ROC you have to take the value of the pole. So the upper part will be 0. So for ROC, if you are taking pole means z minus a equal to 0, you have to equate to 0. After equating to 0, you will be getting z equal to a. Okay. So that's for this a. That's how you will be getting the a value. Okay, for ROC, but this sign gets differs. Okay, this sign gets differs. Why it is getting differs means, why it is differing means, the thing tricky part over here is that the signal. You have to check with the signal. Here the signal is right-sided. Okay, it is positive. Okay, but over here if you are seeing the signal means it is left-sided. It is a left-sided signal. Why this means it is negative. So negative taking common out means the signal starts from minus of n plus 1. Okay. So if it's taking minus of n plus 1 means for negative or the left-handed signal. So it is a left-handed signal. It is very clear to you. We have seen in the ROC diagram also. So if it is a left-handed signal means you will be putting less than. Okay. The same thing if it is a right-handed signal means you will be putting z greater than a. Okay. So that's the step for finding the ROC. So we'll be doing some examples with respect to that. Seeing means it will be clear to you. So now we will be moving to example number. It is example 3. It is example 3. So this example 3, what you have to see is, we are going to, the given signal is x of n. X of n is del is nothing but impulse function n minus k. Refers to impulse function. So you know about impulse function. So your impulse function will be having the value at only 0, but only 0 it takes the value. At other points it will be taking the value of 0. Okay. So at the initial condition will be taking 0. Okay. So in generalized format it will be like this. Okay. So with respect to n you can have. Okay. So to find Z transform for this, you have to find the Z transform. Okay. So solution will be getting out. So first write the formula for your x of z. So z transform is equal to x of z n equal to minus infinity to infinity x of n z minus n. Okay, z minus n. Okay. Now if you're taking the Laplace transform in the sense, so you'll be getting the value of x of z. Okay. For all others values will be you can say so this will be n minus k. Okay. So that is instead of n, you'll be putting n minus k over there. Okay. So now what happens? So after substituting with this, we'll be having like this format. So this is the general format for you. So after substituting this, we'll be getting minus infinity to infinity. It is a periodic sequence, so you can take it for 0 to infinity. So x of n will be substituting with del n minus k. Okay, into z of n minus k. Okay, so this takes the value only at 0. For all other values, it will be the same. So it takes the value of 1, or it takes the value at 0. So x of z equal to z power minus k, z power minus k. Okay. So here, what you have to see is it will be z. That is when this k value differs except 0. If k is greater than 0, similarly for all z, so this is your ROC for all z except infinity if k equal to k less than 0. Okay. So this is its impulse function they have given. So I'll be going with some simple problems so you'll be able to understand easily. So yeah, so we have seen about convolution, right? So I have already told about convolution in the previous unit. So here's a problem regarding convolution. So the problem regarding convolution will also be coming under this topic. So this will be example number 4. Okay. So given x of n is equal to 2 comma 1 comma 0 comma 0.5. Okay. The h of n equal to 2 comma 2 comma 1 comma 1. Okay. So here there are 4 samples. For the h of n also there are 4 samples. Okay. So they ask to find convolution of two sequences solution. So the convolution, what you have to do is x of n into h of n. Okay, for this you have to take the z transform. Okay. So you'll be getting, so this is your you'll be getting x of z is equal to, okay. x of z. In general convolution means this is the thing. That is, we have to multiply the both the signals. Okay, x of z into h of z. So now we have to find x of z separately and h of z separately. So for both the things they have given the arrow like this. Okay. So your x of z will be equal to z transform of this 2 plus x1 1 into z power minus 1. Okay, x will be 0 plus 0 into z power minus 2 plus 0.5 into z power minus 3. Okay, now h of z is equal to 2 plus 2 into z power minus 1 plus 1 into z power minus 2 plus 1 into z power minus 3. Okay, now what we have to do, we have to multiply both these things. Okay, then we getting, so yeah, it's right only. If we are taking z transform of this thing, you will be getting this. So if we are taking inverse of this value, you will be getting this. So it will be z of okay. So now we have to multiply both the things, x of z into h of z. We will be getting 2 plus 1 z minus 1 plus 0.5 z minus 3 into 2 plus 2 z minus 1 plus z minus 2 plus z minus 3. So you have to multiply with each and every element. Okay, you have to multiply with each and every element. So after multiplying, we will be getting x of z into h of z equal to 2 plus 6 z minus 1 plus 4 z minus 2 plus 4 z minus 3 plus 2 z minus 4 plus 0.5 z minus 5 plus 0.5 z minus 6. So now we have to, this is the z transformed value. So for this value, for x of n into h of n only you need. So for this value, what you have to do, you have to take z inverse. So if you're taking z inverse means x of n into h of n will be equal to z inverse of x of z into h of z. So the value will be, getting the value as the coefficient terms 2, okay, 2, 6, 4, 4, 2, 0.5, 0.5. So this is the value. Okay, this is the convoluted value. Okay. The next problem, example 5. Example 5. So the given signal is the given signal x of n is equal to 1 by 8 whole power n u of n. Okay, you have to find z transform. So if they are asking to find z transform means you have to find with your ROC. Okay, so now solution, write the z transform formula. X of z equal to summation n equal to minus infinity x of n z power minus n. Okay, so now just apply the x of n, x of z equal to summation n equal to 0 to infinity. It's a unit thing, so unit function, so it is periodic, so you can convert it into 0 to infinity. So 1 by 8 to the whole power n. Okay, 1 by 8 the whole power n. So u of n will become 1 into 1 into z power minus n. Okay. So now what happens is this. So n is there, so we can take common out. So z summation n equal to 0 to infinity 1 by 8 z power minus 1 the whole power n. Okay. So now for this the value will be x of z will become this generally the value will be this is a formula z minus the constant, so z by z minus 1 by 8. Okay. So here there is the pole. Okay, so this is the pole. So how you can say for finding ROC is substitute pole equal to 0. So then your z will be equal to 1 by 8. Okay. Now you have to check whether it is right-handed signal or it is left-handed signal. So this is belongs to a positive. So this right-handed signal, so it will be having greater than. So ROC is sigma is greater than 1 by 8. Okay. So this is what is here. Example 8. So now I think you might be somewhat aware about ROCs and transfer function. So this part is here is how you are getting from here to here is formula. So you can just take the Z transform mathematics and you can see that is here if we are getting a summation n equal to 0 into a into z of minus 1 we are getting means minus n if we are getting means. So this formula will be transformed to z by z minus a. So the same formula is implemented over here. Okay. So now we'll be moving on with the properties of Z transform. Okay. So some of the properties of Z transform will be seeing. It will be similar to that of the things what we have seen in your previous chapter, previous unit. Okay. And the properties of Z transform. Okay. First one is the linearity property. You already know. So as per linearity property, we have already seen. So A into x1 of n, A is a constant, plus B into x2 of n. Okay, we're taking Z transform means we'll be getting A into x1 of Z plus B into x2 of Z and ROC will be getting as nothing but the R1 intersection, that is the region intersecting for this signal as well as for this signal. Okay. The intersection of ROC of these two signals. Okay. So can get it an example for this. So it is example 6. Okay. Example 6. So what they're saying is here the x of n they are given as 1 by 3 the whole power n u of n minus 1 by 2 the whole power n u of minus n minus 1. Okay. If I taking the z transform means it is unit function, okay, similar to the previous formula. If you're taking x of z means you will be getting similar to the previous problem. If you're saying means the same procedure, you will be getting the form as 1 by 1 minus, or else you can take it as z minus 1 by 3 is that you will be getting plus z by z minus 1 by 2. So here your ROC will be sorry, for this the x of z will be, we just solve it and see. So for this the x of z will be coming out with similar to the previous problem you will see. Okay. The same thing you will be having 1 minus 1 by 3 z minus 1 plus 1 by 1 minus 1 by 2 z minus 1. Okay. So here we'll be getting like this. So now ROC how you have to see means you have to first take this signal. Okay. So you have to just write your z like this. Okay. So first you take this signal, and if you're seeing means it will be 1 by 3. Okay. And over here it will be less than 1 by 2. So this is what with respect to your linearity property. Yeah, regarding this, I will be solving another one problem afterwards. So first, you can see all the properties. Afterwards, I will be getting into the problems. The next is the time shifting property. Time shifting. So take it out like this: x of n minus n naught. If we are taking z transforming z power minus, so that is here a delay is given. X of z. Okay. N naught is greater than 0, then ROC is R except 0. Okay. The same thing if n naught less than 0, then ROC is R except infinity. So the same thing we have seen with respect to the impulse function. The same thing. The next is modulation. Modulation. So a power n x of n. This is the first thing what we have seen. We are taking z transforming x of z by a. Okay. So here the ROC will be a R1 less than z into a, that is the constant a into R2. Okay. So this is your modulation property. So fourth one, differentiation in z domain. The differentiation in z domain. So here it is n to x of n. So we are taking zt. So you know about the Laplace transform, we will be putting minus z dx of z by dz. Z transform. Okay. So here the ROC is region R. So they will be giving. Okay. So this one. This one is conjugate property. As per conjugate property, x star of n into z of t, that is take Laplace transform, so we're getting x star to z star. So ROC is the same R. So similar to this, so we'll be seeing problems related to everything. Okay, so this is conjugate property. So after that, time reversal property. So time reversal property. So x of minus n. Okay, so you have to take z transform. X of 1 by z. Okay, so your ROC will be R1 less than 1 by z less than R2. Okay, next is the convolution property. This is what we have dealt with the previous example. The x1 of n into x2 of n, take the transform, we will be getting x1 of z, x2 of z. So ROC is similar to the linearity property, R1 intersection R2. Okay. Next is the initial value theorem. So this we have already studied in your mathematics. You already know. Then assume initial value x of 0. So that is for the first sample. The value will be limit z tends to infinity x of 0. So this one, while solving problem, I'll explain. You'll be able to understand. Okay. Next is the final value theorem. Final value theorem. Okay, final value theorem. So for this final value theorem, and will be limit n tends to infinity x of n equal to x infinity. Yes, because infinity is substituted. So what happens? Limit z tends to 1 minus z minus 1 to x of z. Okay. So these are the properties. Okay. So regarding the properties, we'll be seeing some more examples. Some properties we have seen with examples. So taking in the next class, we will be dealing with that. So I'll be putting this also in terms of notes. Okay. So thank you.